Hello and welcome to this lesson on an intro to Kubernetes. Kubernetes, also referred to as K8s, is a platform that comprises of a cluster, which is used for running containerized applications. If you'd like to know more about containerization of applications, you can check out the Docker series on this channel. A K8s cluster consists of a set of worker machines called nodes. A node can be thought of as a computer system, but it could be a virtual or a physical one depending on the cluster. Just like your local machine, these worker machines can also run containerized applications inside them, and these applications will then consume the node's resources like memory, storage, network, etc. Every K8s cluster has to have at least one worker node. Worker nodes host an entity called as a pod, which is the smallest deployable unit of computing that you can create and manage in a K8s cluster. Pods can contain one or more containers, and these containers have shared storage and network resources. The contents inside a pod are always created as a single whole unit with a shared context. For example, if a pod is specified to have 3 containers, then any copy of the pod will always contain 3 containers. In addition to the worker node, K8s also contains a control plane layer. This control plane layer is responsible for making global decisions about the cluster and its worker nodes, as well as detecting and responding to the state of the cluster. The control plane comprises of many components which also need to be run on some node. While you can have these control plane components run on any node or different nodes, usually all these components are run on the same node for the sake of simplicity. You can see this depicted in this diagram where all the components of the control plane are run on node 4. The node on which the control plane runs is typically called the master node. The control plane contains 4 main components and 1 optional component as shown in this diagram. The main components are Kube API Server, etcd, Kube Scheduler, and Kube Controller Manager. If your cluster needs to be interfaced with cloud providers like AWS or Google Cloud, you will also need a Cloud Controller Manager component in your K8s. Kube API Server is an API server that exposes the K8s API, which allows for both internal components as well as external systems to manipulate objects within your cluster or the state of your cluster via REST API operations. etcd is a consistent and highly available key value store which is used to store all cluster related data. Kube Scheduler is the control plane component that watches for newly created pods, and it makes scheduling decisions to schedule the running of the created pod on specific worker nodes. Scheduling decisions are made based on a wide variety of factors, which are carried out by running a set of functions that scores all the feasible nodes in your cluster. At the end, the worker node with the highest score is picked to run the pod, and the scheduler notifies the Kube API server about its decision. Kube Controller Manager is the control plane component that runs various controller processes. A controller process is a non-terminating control loop that is constantly running and watching the state of your cluster and acts on it when the current state is different from the desired state. For example, if the desired state is to have 2 worker nodes in your system, but your cluster only has 1 worker node up and running, a node controller will respond to spin up a new worker node in the cluster. While there are several controller processes like the node controller, to reduce complexity, they're all compiled into a single binary and they run as a single process. The last optional component is the Cloud Controller Manager that embeds cloud-specific control logic into your K8s cluster. It lets you link your cluster with your cloud provider API by running controllers that are specific to your cloud provider. If you run K8s on-premise or on your local machine, the cluster will not have a Cloud Controller Manager. One important thing to note here is that every component we've discussed so far in the control plane can scale horizontally. That is, you can have more than one instance of your component to cater to the load on your cluster. For example, if several requests are being made to the Kube API server, you can run more than one instance of the Kube API server and divide this load between these instances. Every worker node in a K8s cluster has these components running on them: a container runtime, a kubelet, and a kube proxy. These components help maintain running pods and they provide the K8s runtime environment. A kubelet is an agent that runs on each node in the cluster, and it ensures that containers are running in a pod and are healthy. It also registers the node with the API server. The kube proxy is a network proxy that runs on each node and it maintains network rules associated with the node. These network rules define and allow network communication to your pods from either inside or outside your cluster. The kube proxy can do simple TCP stream forwarding or round-robin TCP forwarding across a set of backends. Since pods run containers and containers require a container runtime, example Docker, every node also contains a container runtime software installed. Kubernetes supports several container runtimes like Containerd and CRI-O, but Docker is usually the popular option. In this lesson, we covered what a Kubernetes cluster is and what it contains. We also covered the components in the control plane as well as the components in nodes. Thank you for watching.